This is AP Calculus AB Section A, and this is Unit 3, Lesson 5. We're going to look at secant lines and the average rate of change. What's new in this lesson is not the average rate of change. You've already done that. What is new is the idea of a secant line. A secant, by definition here, and this goes back to circles and what you learned in geometry about lines involving circles. So in a circle here, or a curve, a tangent line is a line that just touches the circle one time. That's a tangent line. Okay? Tangent lines touch once. Secant lines, on the other hand, touch twice. Okay? So a secant intersects the curve twice. This is a secant. This is a tangent. Okay? In the case of a curve other than outside of a circle, forgetting about a circle, let's say we've got some function, right, f of x. A secant is a line that intersects 2 points on the graph, at least 2 points. Okay? It could possibly intersect more than once, but it intersects more than once. This is a secant. Okay? Because the secant touches twice. Now the way I've drawn it, it's going to intersect another time down here, but that's beside the point. This is a secant line. And a tangent line is a line that touches just once. Now, mind you, it can touch elsewhere on the graph, but it's still considered tangent. Okay? Because it just touches the curve but does not cross over. So this is considered a tangent line. Okay? And so you recall the average speed is the final position minus the initial position divided by the final time minus the initial time. If you probably notice or hopefully understand, this is change in y over change in x, its slope, or a rate of change. Okay, and we talk about slope or rate of change anytime we talk about something that changes over another quantity. So miles per hour, feet per second, miles per gallon, pounds per square inch, pounds per minute. Anytime you have per or can express it as something per something, you're talking about a rate, a quantity that changes over in relation to another. Okay, and that is average rate of change or average speed in this case. So let's set up a scenario. Let's say we're on a planet here, other than the Earth, because the Earth has very specific gravity here. Let's say the distance an object has fallen under gravity is equal to 6t squared, where t is time in seconds, d is distance in meters, right? T is time in seconds. And d is distance in meters. Okay, and you've been given this problem before where you say, find the average speed from 2 seconds to 3 seconds. Okay, And in which case you do this. The speed average is 6 times 3 squared minus 6 times 2 squared divided by 3 minus 2. Okay? 6 times 3 squared minus 6 times 2 squared divided by 3 minus 2. And we end up with 6 times 9 minus 6 times 4. 3 minus 2 is 1. 6 times 9 is 54. 6 times 4 is 24. 54 minus 24 is 30. 30 over 1 is 30. So it's traveling, and its average speed during that time is 30 meters per second. 30 meters per second. But what's more interesting is to look at this graphically. So let me pull up Desmos here. Okay. And let me graph the function. Now, y and x are the variables of the day in Desmos, 6x squared. Okay. And I'm going to plot a couple of points. I'm going to plot 2 and 6 times 2 squared. You'll recognize that as 6t squared, right? And I'm going to plot 3 and 6 times 3 squared. Now, right now you can't see much in the graph because the numbers are too big. 6 times 3 squared is 6 times 9, 54. So we need to change our window here. Let's do our x-axis from 0 to 4 to 5, 0 to 5. And let's do our y-axis from 0 to 60. Okay, there we have it. Okay, and so you've got these 2 points, and what we have essentially done is we have found the slope of the secant line that goes through them, right? The slope of the secant line that goes through them. I can plot the secant line in Desmos by using the slope-intercept form of a line. Not the slope-intercept, the point-slope form of a line. So I'm going to say y minus one of the y values. I'm going to go with the blue point. Y minus one of the y values, 6 times 2 squared, equals the slope. Now the slope is change in y, 3 squared minus 2 squared, or 6 times 3 squared. 6 times 3 squared minus 6 times 2 squared. All over, and we're just doing the slope, divided by, and you may recognize the slope is the average speed, right? 3 minus 2. There's that formula again. Times x minus the x value, 2. Okay? And I'm just using y minus the y value equals mx minus the x value, right? And you'll notice that we've got the graph of the secant line that goes through, right? And the slope of the secant line is change in y, 54 minus 24, which is 30, over 3 minus 2, which is 1. So it has a slope of 30, right? The line has a slope of 30 and goes through the point 224 and 354, okay? All right, so hopefully that makes sense. When we find average rate of change, we are actually finding the slope of the secant line, a secant line that goes through 2 points on the graph. And that's the big idea. That really is it. We're going to extrapolate that, and you combine this with what we've been learning about limits in the next lesson to talk about the slope of a tangent line instead of the slope of a secant line.